What is time? A journey through humanity's greatest mystery. Welcome to Blissful Heaven, where we explore the most profound mysteries of our universe. I'm your host, Dev, and today we're tackling perhaps the greatest puzzle of all. What is time? Think about it for a moment. Time is woven into every aspect of our existence. We're all time travelers, moving forward at the rate of 1 second per second. Or are we? The nature of time has puzzled philosophers, physicists, and poets since time immemorial. Chapter 1: The Human Experience of Time. Let's start with something seemingly simple. How do you experience time? Right now, you might be walking, driving, or perhaps sitting quietly with a cup of coffee. You're experiencing what we call the present moment. But here's the thing: by the time your brain processes this very sentence, it's already in the past. Our perception of time is deeply personal, yet universal. We all know the feeling of time flying by during enjoyable moments, or crawling painfully slow during tedious ones. Einstein himself once said, "When you sit with a nice girl for 2 hours, you think it's only a minute, but when you sit on a hot stove for a minute, you think it's 2 hours." That's relativity, but this subjective experience of time isn't just about emotion. It's rooted in our biology. Deep in our brains, the suprachiasmatic nucleus acts as our master clock, orchestrating our circadian rhythms. These daily cycles influence everything from our sleep patterns to hormone production, body temperature, and even our cognitive performance. Consider this: your body is actually running on multiple timescales simultaneously. Your heartbeat, breathing rate, digestive system, and cellular processes all operate on different temporal rhythms. You're not just a being in time, you're a collection of biological clocks. Chapter 2: Cultural Perspectives on Time. Let's step back from biology for a moment and consider how different cultures understand time. Western societies tend to view time as linear, a straight arrow moving from past to future. But this isn't universal. Many indigenous cultures view time as cyclical, like the seasons or the motion of celestial bodies. The ancient Maya developed incredibly complex calendar systems based on multiple overlapping cycles. Their long count calendar spans over 5,125 years, reflecting a sophisticated understanding of astronomical cycles and temporal patterns. In some Buddhist traditions, time is seen as an illusion maya, a construct of our minds, rather than a fundamental aspect of reality. The ancient Greeks had 2 words for time: chronos, representing chronological or sequential time, and kairos, meaning the right or opportune moment. Think about how we talk about time in different languages. In English, we speak of time as a resource. We spend it, save it, waste it, or run out of it. Some cultures place the future behind them and the past in front. After all, you can see what's already happened, but the future remains unseen. Chapter 3: The Physics of Time. Now let's dive into the physics, where things get really strange. In 1905, Einstein's special theory of relativity showed us that time isn't absolute. Time dilation is real. The faster you move relative to someone else, the slower time passes for you from their perspective. This isn't science fiction. It's been proven countless times. GPS satellites have to account for time dilation in their calculations. They're moving faster than us on Earth's surface and experiencing weaker gravity, both of which affect how time passes for them. Without these corrections, your smartphone's navigation would be off by miles. But that's just the beginning. General relativity revealed that space and time are actually 2 aspects of a single entity: spacetime. Gravity isn't just a force, it's the curvature of spacetime itself. The stronger the gravitational field, the slower time passes. If you were watching someone fall into a black hole, from your perspective, they would appear to slow down and freeze in time at the event horizon. Here's something even more mind-bending. According to the equations of physics, time could theoretically flow backwards. There's nothing in the fundamental laws of physics that requires time to move forward. The arrow of time we experience, where eggs break but never unbreak, where coffee cools but never spontaneously heats up, comes from something called entropy, the tendency of systems to become more disordered over time. Chapter 4: Quantum Time. At the quantum level, time becomes even stranger. In the quantum realm, particles can exist in multiple states simultaneously until they're observed. This quantum superposition raises profound questions about the nature of time itself. The Wheeler-DeWitt equation, sometimes called the time-time equation, suggests that at the most fundamental level, time might not exist at all. Some physicists argue that time is an emergent phenomenon, like temperature or pressure, rather than a fundamental aspect of reality. Consider the quantum delayed choice experiment, where decisions made in the present seem to affect events in the past. Or quantum entanglement, where particles maintain instantaneous connections across vast distances, seeming to transcend our normal understanding of cause and effect. Chapter 5: The Arrow of Time. But if time could theoretically flow backwards, why do we only experience it moving forward? This is the arrow of time, and it's intimately connected to entropy, the measure of disorder in a system. The second law of thermodynamics states that the total entropy of an isolated system always increases over time. This gives us the thermodynamic arrow of time. It's why hot coffee cools down, why buildings decay, why we age. The universe began in a highly ordered state at the Big Bang and has been becoming more disordered ever since. But here's a fascinating question. If entropy always increases and the universe began in a low entropy state, why was the early universe so orderly? This is known as the past hypothesis, and it's one of the deepest mysteries in physics. Chapter 6: Time and Memory. Our experience of time is inextricably linked to memory. Without memory, would we even perceive time's passage? Think about how time seems to speed up as we age. This might be because when we're young, everything is new and memorable. As we age, our experiences become more routine, creating fewer distinct memories. Studies have shown that our brains don't record time like a video camera. Instead, we construct our sense of time's passage from key moments and changes. This is why time seems to fly when we're engaged in routine activities but slows down during novel experiences. Consider people with amnesia or other memory disorders. Their experience of time can be radically different from ours. Some live in an eternal present, unable to form new memories. Others lose their ability to project themselves into the future, showing how closely our concept of time is tied to our ability to remember the past and imagine the future. Chapter 7: Time Travel. Now, let's talk about everyone's favorite time-related topic: time travel. According to physics, time travel to the future is not only possible, we're doing it right now, just very slowly, and we could do it faster. If you could board a spacecraft traveling at 99.5% the speed of light, you could experience 1 year while 50 years pass on Earth. But what about traveling to the past? Here's where things get complicated. While Einstein's equations don't explicitly forbid backwards time travel, it would require exotic forms of matter and energy we've never observed. And then there are the paradoxes. The grandfather paradox is the most famous. What if you traveled back in time and prevented your grandparents from meeting? You wouldn't be born, so you couldn't travel back in time, so your grandparents would meet, so you would be born, and so on. Some physicists propose that the universe protects itself against such paradoxes through what's called the Novikov self-consistency principle. Essentially, anything that might create a paradox is impossible. Others suggest that time travel to the past would create alternate timelines, avoiding paradoxes altogether. Chapter 8: The Future of Time. As we peer into the future, our understanding of time continues to evolve. Quantum computers might help us better understand time at the smallest scales. New theories in physics suggest that time might be quantized, coming in discrete units like pixels on a screen. Some scientists are working on more precise atomic clocks, so accurate they could detect changes in the passage of time from moving a few centimeters higher in Earth's gravitational field. These ultra-precise measurements might reveal new aspects of how space, time, and gravity interact. And what about the far future? If the universe continues expanding forever, as current evidence suggests, what happens to time? In the very far future, all stars will burn out, black holes will evaporate, and the universe will approach a state of maximum entropy. In this heat-death scenario, would time still have meaning when nothing changes anymore? Chapter 9, Time and Consciousness. Let's conclude by considering perhaps the most personal aspect of time, its relationship to consciousness. Our awareness of time's passage might be fundamental to what makes us conscious beings. Some philosophers argue that consciousness itself might be what gives rise to our experience of time's flow. After all, in dreams, time can work very differently. We can experience what seems like hours in just a few minutes of sleep. The present moment, what we call now, is a psychological construct. By the time we become aware of any sensation or thought, it's already in the past. Our consciousness creates a seamless narrative from discrete moments, giving us our sense of time's continuous flow. Chapter 10, Living in Time. So what does all this mean for us, living our lives in time? Perhaps understanding time's complexity can help us appreciate each moment more fully. Whether time is fundamental or emergent, linear or cyclical, absolute or relative, our experience of it shapes every aspect of our existence. As we wrap up our exploration, consider this: every moment you experience is unique in the history of the universe. The present is where possibility becomes reality, where the quantum wave function collapses into definite states, where consciousness meets existence. We've traveled from the human experience of time through cultural perspectives, delved into physics and quantum mechanics, explored the possibility of time travel, and contemplated time's relationship to consciousness. And yet, in many ways, time remains as mysterious as ever. Perhaps that's fitting. Time might be the universe's way of keeping everything from happening at once, or it might be an illusion created by our consciousness to make sense of change. Either way, it remains one of the most fascinating aspects of our existence. Thank you for joining me on this journey through time. Until our next deep dive, keep questioning, keep exploring, and make the most of every moment you have.